Okay, let's give you guys some practice. So this is your natural log of x graph. Natural log of x graph looks like this, and I want to draw a straight line going through the origin where it just touches the natural log graph just once. Because if the gradient is too shallow, then you're going to touch it twice. If the gradient is too steep, it's never going to touch. So find the equation of this straight line where it just touches the natural log graph just once, and it must go through the origin. So press pause and have a go. Okay, so to do this, you could ask yourself, what's so special about this location? Well, you need to make the demand that at this location, the gradient of this must be the same as the gradient of this. And you also need to make the second demand. The second demand being the y value, the y value of this straight line must be the same as the y value of this line. So in order to find out the equation of this straight line, you need to make those two demands. So let's start again here. We are trying to seek mx plus c. Because we know this straight line goes through the origin, then c must be 0. So you can forget about c. So this equation becomes this. So making our first demand is that we demand the gradient of this to be the same as the gradient of this. So differentiate this, that will then give you this, and then differentiate this, that will then give you this. So this thing here, dy by dx here, allows us to work out the gradient anywhere. Well, x could be anywhere along here, but let's just call this location. Let's just call this location A. So at this location, at this special location here, A, this location here, put A into here. So that would be 1 over A. So the gradient at this special location, remember, we don't know where A is. Let's just call it A, and then later on we're going to try and work out the location A. So at this special location here, the gradient will be 1 over A. Remember, we are trying to make the demand that the gradients here must be the same as the gradients here. So at this location, you would put A into here. So m equals 1 over A. So now we can put this into here. So our equation is going to be 1 over A x. But the thing is, we don't know where A is. A could be anywhere along here. So we need to work out this location A. So hang on. So making our second demand. Our second demand is that the y value of this must be the same as the y value of this. So our second demand is that the y value of this must be the same as the y value of this. So remember, x could be anywhere along here. X could be anywhere along here. But we want to seek out this special location, A. So we would put this into here and into here. So that will, this thing here, when you put A into here, it gets multiplied to the top. A over A, it will be 1. This will be natural log of A. Remember, we are trying to seek that location A. So now exponentiate both sides. That will then give us this. And in a way, these two cancel each other out. That will then give you this. Our location A is actually E. The location here, this location here is actually the number E. The number E, roughly 2.7 something. So this thing here, you can put it into our gradient here. So now it's going to be 1 over E, and then put this into here. So our equation is actually y equals 1 over E x. So this is our gradient here. Well, if you get a graph plotter and plot natural log of x, and then get and then for the second graph plot 1 over E times x, and you will get a straight line that will touch it just once. Okay, so our final answer is y equals 1 over E x. This is our final answer. Okay.